As chairman of the board, I'm a heart failure cardiologist. I've been in this field for well over 30 years, and this is honestly one of the most exciting developments of a new solution for the problem of heart failure I've seen in the whole of my career. So I've been practicing. I set up Europe's largest heart failure clinic some 20 years ago. I've researched on heart failure over that whole period, and I've led and trained many of the heart failure leaders now populating European centers, and I've been president of the Heart Failure Association. But very importantly, I've also realized through work in MBA that you have to take an idea from the laboratory. If you want to make it have an impact, you have to actually work out the commercialization strategy, because it requires significant investment and resources to do all the necessary work to prove it works and it's safe. And that can take well north of $100 million, probably more like 200 or 300 for most newly developed treatments now. So you absolutely have to also understand the importance of patents, commercialization, investments, shareholders, and taking people from a variety of disciplines on the journey. And that's what we've done with ESN Cleer. Here I took down there my past history of some 30 patents and 3 biotechs I've founded that have gone on to sign very substantial deals. I believe ESN Cleer is really the most exciting of these, which is why I've been so proud to be associated and be chairman of it. The nature of heart failure, it's a clinical syndrome. It's not a single disease, but we had got some very exciting biomarkers. So we began to work on that and develop that further and say, well, maybe biomarkers could do more than just simply detect disease. Maybe they could identify people in a very precision way who have a particular type of disease, and in particular, people who will respond positively to a new treatment and be at less risk of side effects. And that's the holy grail of what we now call precision medicine or personalized medicine, to work out a way to identify the exact people who need a certain drug and who are highly tuned to respond to it. So we developed the biomarkers in that direction. And very quickly, we got a lot of excitement from Big Pharma, having thought it through, that they were interested in developing their own blockbuster drugs using our precision targeting mechanism. Rather than waste our money trying to partner with people with their own drug, can't we have our own drug? We identified some candidates, and one in particular who I'd worked on very extensively some years back, that was a true blockbuster that had just failed for one minor problem, which in retrospect, we know we could have avoided. And that was now in its native form of patent, but we could reformulate it, reestablish protective intellectual property, and redevelop it with absolute confidence it will work very well in a variety of the types or syndromes of heart failure. And that's what we've been working on building up a drug company stance where we've got that precision medicine focus on the complex series of disorders of heart failure, a really exciting drug that we can now newly instill with protective intellectual property and target for particular, what we call orphan types of heart failure, particular causes of heart failure that are simply not treatable by any other condition. And that's been a shift and a learning curve for the company, and it's grown enormously. And now it's got a very, very attractive story. So what I've alluded to is the fact that heart failure is important. We know that. It's one of the most prevalent disorders in the modern world. So the biggest problem is that we don't detect people early enough, and we can't detect the various pathways whereby people get heart failure. We tend to wait till it's obvious, manifest, and then we do a salvage operation. We want to get in earlier and detect particular types of heart failure so we can intervene before they get to those grim statistics I showed you. There are two main types of heart failure. On the left, you see that the main left pumping chamber is enlarged, the wall is thin, and it's what we call remodeled. That's heart failure with reduced ejection fraction, we now call HFrEF. There are multiple treatments and work in that, but it's really plugging holes in the dike. we can reduce mortality rates by 10 or 20%, but it still leaves very high mortality rates. And there are now about 9 treatments. So it's a bit of a problem, because if you develop a new treatment, you're on top of another 9, and you get right down the guidelines recommendation, and uptake's very slow. The different type occurs in older people, and that's where the heart muscle gets thicker and stiffer, shown here. They also have a reduced ability of the heart to pump blood around the body, but it's due to a small, stiff heart rather than a big, baggy, weak heart. And that, until very recently, had no treatments that worked at all. It's the type of heart failure you get in older age. It's not normally associated with heart attacks. It's associated more with the chronic effects of hypertension and fibrosis, inflammation, and obesity. That's called HFpEF. And we only have one drug class that's worked, and only in the last 2 years. So we believe that group of conditions, this half of heart failure, is really where the unmet need is. But, and that's a huge problem and why previous treatments haven't worked, it's not a single disorder. It's about 20 or 30 separate disorders that just look alike. And we believe that with our new drug approach, we can target several of these forms of HFpEF in a much more precision way, which has multiple advantages. We can break the problem down earlier. We can get more precise treatments. And it's also classified as orphan disorder, which means it's not millions and millions of people. It's more hundreds of thousands, which means you get a quicker route to registration. You only need to do one clinical trial, and you can justify much higher prices because you're not threatening to blow the whole healthcare budget. So our strategy is to take this HFpEF type, which itself can be broken down to various types. One of which, the one that we know least about, is a thing called restrictive cardiomyopathy. It's before the heart gets totally thickened, it functions as a bit stiff, and it's what we call restrictive physiology. And it has a number of rare causes or less common causes: amyloid protein, sarcoid, iron overload, eosinophilic, and there are multiple others. And each of those alone is a separate disorder, and many of them classify as an orphan disorder. If we can develop this drug with particular effects on sarcoid and iron overload, for example, then we can prove it with a single trial and get very early FDA and European regulatory, along with Australian TGA approval. And because it doesn't threaten to blow the whole healthcare budget, you can also justify much higher prices to reimburse your development costs much more quickly. Our repurposed drug, ESN TX005, is, we know, extremely likely to be effective in these conditions, but it's never been tested in these specific disorders. So we believe we can design affordable drug trials to prove it and get very early approval. And I mean within a few years, and not the conventional 10 to 15 years, starting off with a new drug for a common disease would cause.